Hey guys! So this is the Tricky Topics video for chapter 15. In this video, we're going to cover reading the codon chart, going from DNA or mRNA to our protein with our amino acid sequence. And then in the next video, there's going to be a discussion on tRNA charging, initiation, elongation, and bacterial translation. So let's go ahead and get started with reading our codon chart. So the codon chart is this image that you see off to the side with all of those 3 letters in the middle and the little bases on the outside. So something that's super important about the codon chart is that it is for mRNA. So you can only read this codon chart if you're looking at mRNA. And in addition to that, you have to make sure you're reading the mRNA from 5' to 3'. If you were to read it from 3 to 5, the codon chart doesn't work. Codon chart is for mRNA from 5' to 3'. So direction is super, super important here. And it's called a codon chart. So what's a codon? A codon is a sequence of 3 nucleotides that are found in mRNA. So you'll notice that there's 3 sides to this codon chart and each has some letters. That corresponds to the first, second, and third nucleotide. And then if you line them up, they would find a spot in the middle. So let's do a short example really quick. Let's say that I had an amino acid sequence on my mRNA that was 5' G, C, U, 3'. The G, I look on my left side and I find where G is, which is right here, meaning that I'm only going to have something in this bottom row for sure. I look at my second nucleotide, which is a C. Now I go to the top. I find my C, meaning I'm looking in this column. And now we look at where they intersect. And you'll notice that they intersect in that bottom one in the middle, or the second one over from the left side. So that means that my amino acid definitely has to be in here. And obviously they're all the same, but they're not always all the same. So finally I look at my last nucleotide, which is a U. I go to the last side right here where it says third base, and I move my U over and see where does that line up, and it lines up with alanine. So GCU would mean alanine. And you'll notice that there's a couple places here where we have the word stop written. Stop is not an amino acid. This just means end your sequence. So your last amino acid would be the one that was right before the stop. You're not actually going to write down the word stop. All right. So now we've been talking about amino acids. What even is an amino acid? So on every single amino acid that we have, and we have 20 total, there's going to be 3 groups that are present on all of them. You have an NH3 group, or NH3 plus group, which is an amino group. You have COO minus, which is a carboxyl group, and you also have a hydrogen. And your 4th group is going to be different for every single amino acid. And generally, this is just notated as R. For a specific amino acid, that R is going to look different. So the R is not actually what it is. It's just what we use to say it's different in every single one. And every single R group, in addition to having some different sequence, can also have different properties. So some are going to be basic, some are going to be acidic, some are polar, some are nonpolar. So switching out amino acids could have big consequences for our protein if you're switching out something that's polar for nonpolar, and likewise. So when we're talking about directionality of amino acids, I'm going to go back and talk about directionality of DNA and RNA, because so far everything we've been talking about has been 5' to 3', 5' to 3', 5' to 3'. And that's based off a phosphate on the 5' and the OH on the 3' of your sugar. But in proteins, we don't have 5' phosphates. We don't have 3' OHs. So we can't use the terms 5' and 3' when it refer to anything. So instead, what we're going to use are the terms N-terminus and C-terminus. N refers to your amino group, that's your NH3+. C refers to the carboxyl group, that's your COO-. And whenever you're reading a protein, you read from N to C. So like we read mRNA 5' to 3', you read a protein N to C. And there's a way to look at your mRNA and tell where's that N-terminus and C-terminus going to be. The 5' end of your mRNA is the N-terminus of your protein, so 5' and N. And the 3' end of your mRNA is the C terminus of the protein. And you think about that C rhymes with 3, so C and 3 goes together. Therefore, N and 5 must go together. All right, so let's do some steps for finding an amino acid sequence, and then we'll do some practice with this. So step 1, just look at what you're given. Are you given mRNA? Are you given non-template DNA? Are you given template DNA? If you're given mRNA, you're good, you'll go on to the next step. If you're not, and you're given something different, you need to change it to mRNA. So remember the relationship between non-template DNA and mRNA, they're parallel, they have the same nucleotide sequence except T and U. Template DNA and mRNA are anti-parallel and complementary. So based on what properties you need to use, you're going to change it to mRNA. Step 2, is our mRNA in the right direction? We need it to be 5' to 3'. So if it's already 5' to 3', you don't have to do anything, you're done. You can go on to the next step. If it's written 3' to 5', go ahead and write it 5' to 3' instead. And finally, when we have mRNA and it's written in the 5' to 3' direction, we're going to use our codon chart to read our mRNA from 5 to 3. And remember, the protein would be written from N to C. All right, let's do some practice. So, I'm given mRNA, 5', nucleotides 3'. So first, what am I given? I'm given mRNA, and my mRNA is already written in the right direction as well. So that's steps 1 and 2. We have mRNA, step 1, check. It's written 5' to 3', step 2, check. We can start transcribing it, or translating it, sorry. So CGU, if I look at my codon chart, C is on the left side, G is at the top. That corresponds to this box right here. So then I see where U is, and U tells me that it's arginine. And another thing that I'm going to notate is the N terminus on the same side where that 5' is. So the 5' and the N go together. My next codon is GGC. So I find G, that corresponds to this bottom one. And then I find my C, glycine. And then I have UGA. So I have U and G corresponds to this top box. A gives me a stop. So remember, I'm not actually going to write down the word stop. All I do is end my sequence, and I'm going to show that by adding my C terminus to show that it was the end. All right, let's try our next one. Now I'm given non-template DNA. So I don't have mRNA, so we still need to complete step 1, because step 1 is all about making our mRNA. So I know that non-template DNA and mRNA are going to be parallel to each other. So if my non-template is written 3' to 5', my mRNA has to match that and also be written 3' to 5'. And I know that the nucleotides are going to be the same, except T is U. So CUU, GAA, CGC. So it's the same exact thing, except every single T is a U. All right. So step 2, is my mRNA in the right direction? No, it is not. Right now it's 3 to 5, and I need it written 5 to 3. So I'm going to write it 5 to 3 instead, which means that I need to read my mRNA that's on the top in purple backwards. So it's CGC, AAG, UUC. So I'm reading it this direction. So CGC, AAG, UUC. Now I have mRNA, it's written 5 to 3. I can go over to my codon chart. So CGC would give you arginine. And that will be with my N terminus since I'm reading from my 5' end. AAG would give you lysine. And finally, UUC, U, and C would give me phenylalanine. And since that's all that I'm given, I'm going to go ahead and put my C terminus on the end right there. And for our last one, we're given template DNA. So I need to do step 1, which is all about making my mRNA. So I need to change my template DNA into mRNA. I know that my template DNA and my mRNA are anti-parallel to each other. So if my template is written 5 to 3, my mRNA is written 3 to 5. And they're complementary. So I'm no longer just switching T's for U's, I'm actually doing the complementary base pair. So T is complementary with A with U, G with C. And then C is complementary with G, T with A, G with C, T with A, T with A, and A with U. All right, step 1 is done. I have mRNA. Step 2, is it written in the right direction? No, it is not. Right now it's written 3 to 5, and I need it written 5 to 3. So I'm going to flip it and read it in that direction, UAA, CAG, CUA. So I have UAA, CAG, CUA. Now I have mRNA, it's written 5 to 3, so I can start translating it and reading my codon chart. My first one is UAA, UAA, stop codon. So that means that I don't have any sequence right here because the first one that I have written down was a stop. I don't just go on and do the other two because my first one didn't work out. If once you hit a stop, you're done, you can't keep going. So that was an example, or a couple examples, reading codon chart at different places you might start. So practice with those, make sure that you feel comfortable given different directions, given different types of nucleic acids, and making sure that you can get it to mRNA, get it 5 to 3, and then read the codon chart. All right, the next video we will be going over some of the steps of translation, tRNA charging, initiation, and elongation in bacteria.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are currently enrolled as a Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need to know about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online through Navigate, or just drop in during our open business hours. For more information about our current services, please visit our website. Thank you.